Okay, here's the question then. There's the graph. And here's the question, parts A and parts B. Okay, I've summarized it here. We need to use the mid-ordinate rule with 5 strips between 0 and 4 to evaluate this integral, which corresponds to this shaded region here. So if we look at A, we're going from 0 through to 4. There's 4. There's 0. Okay, with 5 strips, I've done 2, 3, 4, 5 strips, so it will be 0.8, 1.6, 2.4, 3.2. So the mid-ordinate values are here, aren't they? In the middle of each strip. This would be 0.4, this would be 1.2, this is 2.0, this is 2.8, and this is 3.6. So there's the mid-ordinate values, xy's. So let's have a look at it then. So x0, x1, x2, x3, x4. So we've got 5 strips and 5 x ordinates. There's the x values. Now we need to work out the y values. 27 plus x cubed. (27 plus 2 cubed is 8. 27 plus 8 is 35. And then the last one, 27 plus 3.6 cubed. So, if we label that I, we can write down the answer now. So I is equal to, well, it'll be 0.8 times the sum of all those y values. I equals 0 to 4. So that's equal to 0. Well, let's just work it in the calculator then. So let's do it here. So I'll move the calculator out of the way and just type it in here so that we're all happy with it. So it's square root 0.8 times bracket root 27 plus 0.4 cubed plus root 27 plus 1.2 cubed plus root 27. Oh, no, sorry. 35 outside the square root plus square root 27 plus 2.8 cubed plus 27 plus 3.6 cubed. Close that bracket then for 0.8 times. 25.6 to 3 significant figures, isn't it? 25.6 to 3 significant figures. So that's that. Now part B. So we got the shape of the curve from the picture. So I'm going to flick back to the picture in the actual paper. See, it snakes back and twists up quite sharply here, doesn't it? Okay, so let's draw a typical picture of one of those intervals and see what we get. So here we'd have a curve that looks like this, and then we'd have a strip down here, and we'd have a strip down here. There's our strip, and that would be 0.8, and here would be our value in the middle, and we would take a rectangle here, and because it's twisting up quite sharp, we can see that it's an underestimate. So we see, observe, that this is an underestimate. Simply because this area here and this area here bigger, smaller. So the rectangle in question, you could put that in there with some to spare, so the rectangle would be smaller than the area under the curve.